So yeah, thanks for coming. I'm going to present this work on behalf of Ruben, who did his thesis on this subject, but he can't be here today because of work commitments, so I'm taking over those duties. And so when preparing for the talk, I had a hard time of trying to fit all of these into 10 minutes. And because of that, I thought I would try something different and rather talk about the sightseeing I did in Barcelona the other day. So I also prepared a nice map here, went out from my hotel, then went straight to the park from Gaudi, very nice park. And then I went straight down to Sagrada Familia, which is, of course, a must-see in Barcelona. And after that, did a little bit of shopping on La Rambla. So got a little bit lost around here, but otherwise it was a quite nice trip. And then I spent a lazy late afternoon on the beach before I was heading back to my room. Actually quite near the conference dinner last day. So you might be thinking, what has all this to do with the topic of the talk? And when I explained my trip, I rather focused on the different locations I have visited and not so much on the actual routes I have taken. And indeed, in many cases, if you would like to understand movement patterns, it's not so much about the exact coordinates, but rather about the sites you have visited in a certain order. And so you can abstract from the coordinates using a sequence of sites, basically, which are so-called semantic trajectories. And we thought that this concept could be very valuable for analyzing player movement as well, because it doesn't matter in many cases if you move a little bit more to the left or a little bit more to the right. So we developed, or Ruben developed, a visualization plugin for Unity, which basically allows to derive, analyze, and visualize such trajectories. So it basically starts with tracking the movement of the players while we are moving around in the environment. So we are getting the exact paths at the beginning. And then the user of the tool can basically define areas of interest, like, for example, areas where an important item is located or junctions in the game environment, things like that. And based on those areas of interest, we can then derive those semantic trajectories from the actual movement data we tracked in the step before. And once we have those semantic trajectories, we can analyze them. And for that purpose, we provide three different views. And the main view is a transition diagram, which basically shows the areas of interest using rectangles, and the transition between those using directed arrows. And the width of the arrow basically reflects the amount of movement between certain areas of interest. And by having those semantic trajectories, we have another advantage because we can easily establish a similarity between them. So in our case, we use longest common subsequence, and we use that to group paths using hierarchical clustering. And to show those results of the clustering, we make use of the usual dendrogram visualization. And finally, we have the main 3D view of basically the 3D editor of Unity, which shows the detailed paths of a player or of a group of players as selected from the dendrogram, for example. So we had this tool, and of course we were then interested to see if it's actually of any use. And so we came up with a user study. We developed a small game for it, a single-player 3D game using Unity, because we needed access to the assets and all the stuff, and also because it shouldn't be a completely polished game. So it should still have certain shortcomings in terms of level design, which may or may not show up in the visualization then. Then we collected movement data from about 80 players. So we had them play the game, and we also collected their feedback basically on things they didn't like so much about the game and where they struggled. And we used that later in the study. And the main study itself was with 6 experts from the game industry. Some were designers and some were programmers. And each session took about an hour. And during that hour, we had them play the game, so get familiar with it. And we then shortly introduced the tool. And the main part was basically a long open-ended task where participants could use the tool and had to analyze the data with it. And finally suggests improvement for the game. And during that hour, we observed them, we recorded for thinking aloud, and we also conducted short interviews regarding certain aspects of the game. So for example, we asked them about the usefulness of it, and in that regard, all but one expert found that it's quite useful for informing level design in general. And we were quite happy with that, because that's the main goal of the visualization. But we also had a little bit of other feedback, like 3 experts found it valuable for spotting exploitable areas, and they thought that could also be valuable for multiplayer games, which ours was not. We had 2 experts thinking it was useful for assessing and balancing the difficulty, and we also had one, a programmer, who immediately thought of bugs, and thought that could also be useful to spot such bugs in the level environment. In terms of the 3 views, 3 experts explicitly said that they preferred the transition diagram because it offered a nice overview of the general movement flow in the game, and also because it allowed them to see how many players reached a certain point. On the other hand, we also had 4 experts, mostly those with a design background, who struggled with getting any insights from the dendrogram visualization because we were not used to it. So we really struggled on how to interpret that rather technical representation. So in general, we can say that the experts could draw conclusions about the different paths the players were taking, how many players reached a certain point in the game, and also where players spend their time, which is also indirectly noticeable from the movement patterns. And we were also quite happy to see that the experts could identify issues which were actually experienced by the players. And for that, we basically compared the player feedback with the experts' insights. So to give you a few examples, we had, for example, 2/3 of the players who said that they struggled with navigating the map. So we got lost at some point. And this could be identified by the experts using the visualization. We also had 6 players who said that they got stuck at some point, they couldn't proceed any further, and yeah. So, and again, the experts could spot those areas where they got lost with the help of this kind of visualization, and also with the dendrogram, for example. And lastly, and this is a quite interesting case, we had 4 players who were not aware that they could control the camera. And so we just moved around with never changing the camera. And interestingly, they showed up in the visualization as well because they had a very distinct movement pattern. So yeah, so we were quite happy to see that as well. We have a few more results in the paper. For now, to warm up the talk, I would just talk about some general takeaways and possibilities for future work. First of all, of course, I'm happy to say that semantic trajectories are indeed helpful for analyzing player movement. But the important thing here to say is that it's also important that the users can also access the detailed paths if required. So if you want to double check something, for example. One drawback of the visualization we had is that we basically just showed the amount of transitions between those areas and not so much the connection between the incoming and the outgoing paths. So that was lost. And in that sense, future work may focus on better conveying the connectivity between the incoming and outgoing flow. In terms of methodology, it's always quite challenging to assess such visualizations of gameplay data because it's sometimes quite difficult to have a certain baseline or a certain ground truth to which the results can be compared to. And in that sense, we think it by collecting player feedback and collecting experts' insights and comparing those could be quite valuable in this regard. And lastly, a thing which I think is really important here is we should be aware that not all visualizations, even what we think are popular visualizations, are easily or straightforward to interpret for everybody. As for example, we have seen with the designers using the dendrogram here. So in that sense, we should not only take the goal of the visualization into account, but should also carefully consider the visualization literacy skills of the different target users to allow them to make better use of the visualization. And with that thought, that's it from my end. Thanks for showing up, and happy to take questions.
Z-Tubes, New Mexico State. So your earlier map had a number of places that were meaningful, right? Places, that's what defined your map.
Yeah.
My sense was that your tool is extracting like important places automatically.
No, it's
like,
user-guided basically. So the designer or the user of the tool can basically define the areas which he or she thinks are interesting for the analysis here.
So then, is there anything to maybe support discovery of what, right? What I?
So, for example, if a designer is, for example, interested if an item, a key or something which is necessary to proceed further in the game is really found, or it's just somewhere hidden in the wood, he could use defining the key and the door as areas of interest here. But of course, you could derive them automatically from the movement data by using some clustering algorithm, for example.
Thank you.
Hi, Günter.
Hi.
Eric Hofstad, Carnegie Mellon. So I don't know if you're, from what I understood, I assume you don't actually have a great answer to this question. But if not, a really interesting possibility for future work is, so it was cool that your viz helped the designers sort of recover the challenges players profess to experience. But I'm really curious to hear about how does using a tool like this help the designers come up with the solution to the problem that they see? So would this affect not only detecting the problem, but also how they might ideate and think about solving it?
Yeah, I mean, one way they can see it is basically if, for example, an item is missed, so nobody is moving over there, they can have a look at the visualization and move it, for example, to an area where the majority of movement has passed through, for example. So basically, it provides basically an overview of how many players traversed a certain area in the map, given that you have, of course, defined the proper areas of interest. But again, you could use some automatic level subdivision and algorithm to help with that. And I think that would be something for future work, because it's quite a time-consuming process if you really want to have a large level and you need to define lots of those areas.
Hi, Marcelo Gomez from Leiden University, Netherlands. More questions. One, is the tool currently available? Is it possible to download it, basically?
I don't think so. I would have to check with Ruben. But I can let you know.
And the second one is it possible to map movement in 3D space, or is it projected?
So, I mean, the movement is currently tracked in total 3D. We just then project it for visualization onto the plane. So basically, you don't have to do that. So you could basically also visualize it in 3D environment using cubes, for example.
But specifically, areas of interest have to be...
Right now, it's a rectangular quad-like area.
Mm-hmm.
But of course, that could be extended as well, that you're using circles or something like that.
Okay, thank you.
Hello, Günter. Ansgar, Electronic Arts. I have a question. This is super interesting work. Thank you very much. Your example here is traversing an environment effectively. I'm wondering, could you see this being applied to traversing a menu?
Yeah, basically you could do the same thing. Then you would define different buttons or different areas of the menu as your areas of interest.
And the analysis behind it would essentially say.
Yeah, so once you basically have derived those semantic trajectories, it would follow the same steps as here.
All right, thanks.
Okay, let's send more. Günter, Simone, Ruben.
Thanks.
Now we have